Okay, good morning. So let us solve the problems in homework 3. The first question, what is the exact value of the following sum? Cosine 20 degrees plus cosine 40 degrees up to cosine 180 degrees. So let me write the problem on the board. We can start there. Okay, so we are supposed to calculate this sum exactly. And of course, it is clear that these angles, some of them, of course, are famous 60 degrees, for example. You can look it up in the table, but this formula, these angles are not in the formula sheet, so there is no way for you to calculate them individually, even though some of them you can find them in the table, okay? Okay, so the idea should be different. First of all, I want you to understand that these dots make sense. Why? Because it shows that I have cosine 20 degrees, I add 20 degrees, I will get 40 degrees, then I add 20 degrees, I get 60 degrees. Then it becomes clear that every time that I add 20 degrees, eventually I will reach to 180 degrees. So this is just to understand the problem. So it works. I mean, if you go 20 degrees at a time and start from 20 degrees, of course, eventually we will arrive at 180 degrees. So the whole point of this is to use the notion of the supplementary angles. So if I want to review something from the lesson, so let us say, of course, this is one thing that I really want you to remember. So the idea is this. If I have two supplementary angles, meaning that I have two angles adding up to 180 degrees, sines are the same, cosine and tangents are opposite. That is important to remember because this appears a lot in trigonometry, so it's good to know it. But anyway, if you have forgotten that, you need to find it yourself again. So how, let us say that I have an angle theta here, okay, and the xy coordinates of this point, I show them with x and y, okay? So you know that x is cosine of theta and y is sine of theta. Now I want to find the supplement to this angle. Supplement means an angle so that when I add theta to it, it becomes 180 degrees. So it is not that hard to see. If I draw an angle theta from here, then this angle becomes 180 minus theta. So this angle that you see is 180 minus theta, and that is the end point of that angle. And if you draw a precise picture, by symmetry, you will immediately understand that these 2 points are mirror image of one another with respect to the y-axis. So if the coordinates are x and y, the coordinates here are minus x and y. The heights are the same, but the x's are opposite. So this is cosine theta. If I ask you what this is the x-coordinate of this point corresponding to angle 180 degrees minus theta. So this is cosine of 180 degrees minus theta. So one of them is x, the other one is minus x. So it tells me that these are opposite. So cosine of 180 degrees minus theta is minus cosine theta. Of course, you immediately see that the signs are the same. And if the signs are the same, cosines are opposite, when I divide them, tangents also become opposite. Okay. And the next thing is that using this idea, I need to start grouping them. Okay, so how should I group them? I group them in a way that I can see supplementary angles next to one another so that I can use this. Okay, so for example, cosine 20 degrees plus, there is 1 in this list before this, okay? This is 180, so the previous term is cosine of 160 degrees, and I write it here because it doesn't matter in which order I am adding the numbers. Why this is good? Because 20 degrees and 160 degrees are supplementary, and I don't know this number, I don't know this number, but I know that these are opposite. If they are opposite, when I add them up, it becomes 0. So that is the idea. For example, cosine 40 degrees, I take cosine 40 degrees from this list and combine it with cosine of 140 degrees, which is also in this list. Yes, because I am going up every time 20 degrees. Okay, the next one is I will take cosine 60 degrees, and then one thing in my list is cosine 120 degrees. And then I will go to cosine 80 degrees plus cosine 100 degrees. Yes? And one of them is left alone, and that is just cosine 180 degrees. But we don't have any problems with that one because this is in the table, or you can immediately easily find it from the unit circle analysis. Yes? So hopefully you understood that what's going on. So this sum is 0 because they are supplementary, they are opposite. 40 degrees and 140 degrees are also supplementary, they are opposite. That one is 0. The same story here, that is also 0, and that is also 0. So what is left for me is just cosine of 180 degrees, but I want to calculate this because that is very simple. Where is 180 degrees? You start from here, you go 180 degrees, you end up here. The coordinates of that point are -1 and 0. I am interested in cosine, so I will be interested in the x coordinate. So the answer simply becomes -1. Or you just have it in your memory, or you refer to the table of values. In any way, the answer to this sum is just -1. Okay? So now let us go to the second problem. The number a is defined as follows. A is sine 240 degrees plus cosine 420 degrees times tangent 600 degrees plus tangent 315 degrees times sine of 43 times 30 degrees. And then we want to calculate the exact value of 1 minus 4a and write it here in this box. So of course, the first thing that we have to do is to calculate the exact value of a. When we have it, we multiply it by -4 and add 1 to it. That will be the answer that we are supposed to write here. Okay, so let me write it on the board, and then we go and solve it together. Okay, so if we want to continue here, so my way to solve this problem, I want to calculate each one of these individually and then put them together and find a, and when I found a, I put it here and answer the question mark. So that's the strategy. Okay, so what about sine of 240 degrees? Of course, you know that 240 degrees is not a famous angle. You cannot find it in the table, in the formula sheet. So what we're supposed to do, we have to use our trigonometric knowledge to connect 240 degrees to one of those famous angles in the table and use the knowledge of trigonometry to answer the question exactly, because we're supposed to find this out exactly. Okay, so it is not hard to see that this can be written as 180 degrees plus 60 degrees. So the way that I am connecting 240 degrees, I am connecting it to 60 degrees. 60 degrees, one of those famous angles, 30, 45, and 60, yes? And then it shouldn't be hard for you to understand what the value of this is, because if you just draw, let me just draw it here. If I draw the unit circle, yes? If I ask you where 60 degrees is, let us say this is 60 degrees, but then I need 60 degrees plus 180 degrees. So it means that I have to start from here and go half around, okay? And I will go end up at the exact opposite point, okay? So if this is 60, and then this is 180, so from here to here becomes 240. 180 plus 60. And then if the coordinates of the point are x and y, the coordinates of this point is minus x and minus y. So it means that the x coordinates are opposite. It means cosine values are opposite. And the y values are also opposite. It means that the sines are also opposite. Okay, so it means that if you're interested in sine of 240 degrees, it is not exactly equal to sine of 60 degrees. It is minus sine of 60 degrees. Okay? And then sine of 60 degrees is famous. You can find it in the table. I have it in my memory. So it is a square root of 3 over 2. And then I have a minus sign here. So that's the answer. So sine of 240 degrees becomes that number. What about cosine of 420 degrees? Again, you see, I hope that this is not hard. By doing a little bit of exercise, you will get an experience. So what is 420 degrees? 420 degrees is one full round more than 60 degrees. So it is 360 degrees plus 60 degrees, yes? These two numbers added, it becomes 420 degrees. What is it? Why this is helpful? Because you know that the period of cosine and sine are 360 degrees. So it means that every multiple of a full round can be cancelled out. Because by going one full round or any integer multiple of full rounds, I will go back to the same point and the coordinates will be the same. So cosine, tangent, and sine will remain the same. So this is exactly equal to cosine of 60 degrees because I just ignored that. And this one is also famous. I have it in my memory. It becomes 1 over 2. That one, tangent of 600. It's good to know that the period of tangent is 180 degrees. So what does it mean? It means every integer multiple of 180 can be ignored when it comes to tangent. So let me try to write this because 600 degrees is above 360 degrees. I ask myself how many complete 180 degrees I can fit here. Okay, that shouldn't be hard. The answer is 3 times. 3 times 180 degrees becomes 540 degrees. I need to add 60 degrees more. And as I told you, any multiple of half a round when it comes to tangent can be ignored. So this becomes tangent of 60 degrees. And again, this is one of the famous numbers. I have it in my memory. It becomes square root of 3. So I was able to answer all the first 3 ones. Okay, when I go to tangent of 315 degrees, what can I do? I can write tangent of 360 degrees minus 45 degrees. How did it come to my mind? Because I told you that whenever I have an angle and I'm not allowed to use the calculator, I have to be able to connect the angle in some way to one of those famous angles, and I know that 45 degrees is one of them. Okay? Okay, what is 360 degrees? 360 degrees is actually 2 times 180 degrees. I just told you that any integer multiple of 180 degrees, when it comes to tangent, can be ignored. So this 360 degrees is 2 times 180 degrees, so that multiple can be ignored. But be careful, when I ignore that, minus 45 degrees is left. So it becomes tangent of minus 45 degrees. And I hope that you remember that this is, when I was teaching you, I told this under the title of trigonometry of opposite angles. So what was the rule? If I have sine of a negative angle, the negative sign can go out. So let me remind you, let me change my color. So sine of minus theta is minus sine theta. If you see a negative angle, and it is sine, you can pull the negative sign out. If you have cosine of negative theta, it becomes cosine theta. And if I have tangent negative theta, this negative goes out again. So remember, for sine and tangent, the negative sign goes out, but for cosine, the negative sign is completely eliminated. Okay, so here, I move this minus sign out, and then this is one of those famous angles. I have it in my memory. Tangent 45 degrees is 1. I have a minus sign, so it becomes minus 1. Okay? And eventually, I want to come up to calculate this. The reason I wrote it 43 times 30 degrees, because the calculator is not allowed. So I didn't want you to be able to, I didn't want you to start doing messy calculations, okay? Because the idea matters to me here. So how should I do that? So let me calculate sine of 43 times 30 degrees, okay? Okay, I know that the period of sine is 360 degrees, so it means that any integer multiple of 360 degrees can be eliminated, okay? And I already know that if I have 12 30 degrees, 12 times 30 degrees, it becomes 360 degrees. So every 12 times 30 degrees is one full round, and that one full round when it comes to sine can be eliminated. So this motivates me to write this in a way that I can see how many 360 degrees can appear. Okay, so what I will do, I will write it in this form, because I know that 12 times this is one full circle. I ask myself how many 12s I can fit into 43. It's not hard. 3 times 12 is 36, but I have 7 more. 3 times 12 is 36 plus 7 is 43, multiplied by 30 degrees. I'm not saying this is the only way, but this is one way to escape from heavy calculations. So what I will do, I multiply this in, so this becomes sine of 3 times 12, but I multiply this in 30 degrees, plus 7 times 30 degrees. Okay, but what happens here, 12 times, that was the motivation, 12 times 30 degrees is 360 degrees. And I have an integer multiple of 360 degrees in sine. Because 360 degrees is the period, so this totally can be ignored. And then it becomes sine of 7 times 30 degrees, which is easy to calculate, 210 degrees. And then still it's not a famous angle, but then immediately you can connect it to what? To 180 degrees plus 30 degrees. Yes? And I don't want to repeat this. 180 degrees plus 30 degrees is exactly the opposite point to 30 degrees on the unit circle. So the x coordinates are opposite, the y coordinates are also opposite, exactly as I did before. So then it becomes minus sine 30 degrees, and then I have this number in my memory, it's 1/2, so it becomes minus 1/2. Okay? Everything is now in order, so what I will do, I will substitute, I will replace these numbers with the numbers that I got. So then A is equal to, instead of sine of 240 degrees, I put that number. Instead of cosine 420 degrees, I put 1/2. Instead of this one, I put square root of 3. And then what do I have? Plus. Instead of tangent 315 degrees, I put -1. And instead of the final one, you have it on the board, it's -1/2. And then I calculate. Minus, positive, minus, so the answer becomes minus. Square root of 3 is 3. 2 times 2 is 4. Plus, minus, minus is plus. 1 times 1/2 is 1/2. So it's -3/4. Instead of 1/2, I write 2/4. So it becomes -1/4. So that's the answer, exact answer to A, but the question mark is 1 minus 4A. So it becomes 1 minus 4 times that number. Okay, so it becomes 1, 4 and 4 are gone, minus, minus, plus. So the answer is 2. So the answer that you have to provide for this problem in the box is just simply typing number 2 there. Yes. So we type number 2 here. Okay, finally, the last question. The following figure shows the line L with a slope K. If L passes through the point A with coordinates 4 and M, then M squared plus K squared is what? You're supposed to find it and write it here. Okay, the only information that is available that I can use, you see that there is no grids here so that I can read the coordinates, except this one which is given in the problem. That's exactly 3, and this angle is given to you exactly 60 degrees. Finding this slope shouldn't be hard, because if you remember what we went through during the lesson, is that a slope has a geometrical interpretation as well here. The tangent of the angle that the line makes with the positive direction of x-axis is the slope of your line. So don't get confused. This is an angle that the line makes with the negative part of the x-axis. Okay? I want to find the angle that my line L makes with the positive part of x-axis. So this is this angle. And that is 120 degrees, not 60 degrees. So finding k is extremely simple. K is tangent of 120 degrees. Okay, so let us go to the board. Okay, so as I told you, this angle is 120 degrees. So the k value, the slope of my line, is tangent of 120 degrees. But exactly as I just repeated in the first problem, this is the supplement to 60. So 60 degrees and 120 degrees are supplementary angles because they add up to 180. And we just learned that the tangent of supplementary angle is minus the tangent of the angle. So it becomes minus tangent of 60. But this is one of the famous angles. I have it in my memory. It is the square root of 3, so it becomes minus the square root of 3. So k is minus the square root of 3. So the slope is minus the square root of 3. And then you remember the question mark that we are supposed to answer is k squared plus m squared. K squared is found. It is 3. But I have to find m. Be careful. The point M, the point A is given to you with coordinates 4 and M in the problem. So M is the coordinate of this point. Don't get confused with the M that you usually use to write the y-intercept, because you know that in Swedish books, you write the equation of the line as kx plus m. K is the slope, as in this problem, because it is mentioned in the problem that k is the slope. But they haven't mentioned that m is the y-intercept. Why? M is the y-coordinate of one of the points on this, not necessarily that point. Yes. Of course, it is not this point, because this point has x-coordinate 0, but you see that your point has x-coordinate 4. So this point cannot be this, and this means that m is not the y-intercept, even though usually in Swedish books we use m as y-intercept. So not to get confused, let me change the letter that we usually use for y-intercept, because this is already reserved in the problem for this. Let me change it to something like h. Okay? Now, k is already known, so let me put it there. Okay, so this is the equation of this line. But still, this is not finished because I don't know h. So how can I find h? I can use another piece of information that I haven't used so far, and this is this number 3. The point that you see here has coordinates. The x-coordinate is 3 and the y-coordinate is 0 because it lies on the x-axis. And this line is passing through that point. So it means that this point lies on the graph of this equation. This happens if and only if the coordinates of the point satisfy the equation of the graph. What does it mean? It means that if you go to the equation of the graph and replace y with the y value and replace x with the x value, the equality is right, is correct. I will do that. Instead of y, I put 0, minus the square root of 3. Instead of x, I put 3. And the missing part, h, is found now. Because this number is just simply minus 3 square root of 3. I move it to the other side, so I found the h. So h is positive 3 square root of 3. When I know h, I put it back in my equation. So now my equation is completely known to me. Yes? If someone asks you what we have done so far, I just using the pieces of information provided for me to in the problem, I found the equation of this line to be that. But I need to find m. According to the problem, this line is also supposed to pass through this point. For example, if this is 3, 4 is somewhere here, so I know that this, if I continue, probably this point is point A. Because the point with coordinate 4 and on the line is only this one. But the point is that, of course, this value, as you see, is a negative value, but that is your m. But you don't need to worry about drawing a picture. Even if you don't have it, if you have a trouble understanding this, no problems. You can solve it just algebraically. You don't need to visualize it geometrically, even though it's always good to have a good grasp of what the problem is talking about. Okay, anyway, I have that equation. I know that this point lies on the line, so there is one thing to it. If I replace y with y, if I replace x with x, that equality should hold. So I will do that. Instead of y, I put m. Instead of x, I put 4, so it becomes minus 4 square root of 3, and then nothing I can do here, I copy and paste. 3 square root of 3 minus 4 square root of 3 is just simply minus a square root of 3. So coincidentally, the value of this one is exactly the k value. Okay? But then what can I do? I can answer my question mark. The question mark is k squared, which is minus the square root of 3 to the power of 2, plus m squared, which is coincidentally the same here, and this number becomes positive 3, this number positive 3, so the answer is positive 6. So the positive 6 is the number that you have to put in that empty box. And it's also instructive to see it from this picture. I hope that you could understand this, what I said, because you see this point has y coordinate 4. If this is 3, 4 is a little bit on the right. And then if I want to find the point on the line with these coordinates, that's the only one. So it is easily understood that this length is m. Okay, of course not length, because m is an algebraic number. Here you see this length, but with negative value is m. So what can I do? For example, here is 4, here is 3, so this length is 1, and this angle is vertical angle. So if this is 60, that's also 60. So what can I do? I can say tangent of 60 degrees is this length, but this length is not m. Be careful, this length is minus m because m itself is negative, divided by the adjacent side, which is 1. So this m is minus tangent of 60 degrees, but tangent of 60 degrees is square root of 3, so we can get the same answer. So this is a geometrical way to find m. That is an algebraic way to find m. But if you understand what you're doing, you see that they are consistent. Okay. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.